Hello everyone. Today we are going to learn the binary search algorithm. Uh, in my next videos, I will going to solve the problems in which we will use the binary search algorithm. So before we go towards solving the lead code problems, let's try to understand how the binary search algorithm works. Okay. So binary search algorithm is basically a search algorithm. So it's a search algorithm. It takes log of n. Its time complexity is log big of log of n. That is, I have written here. So how it is log of n, we will see. Okay, this is the algorithm, and this is the example we will going to discuss. So let's try to discuss and understand. Okay, so we have this data randomly. I have chosen. Okay, let's suppose this is an array. Okay, so first of all, what we will do, we will set our left and right pointers. Left pointer we will set at start of array, and right pointer we will set at end of the array. But before going towards the algorithm, let's understand basically what the problem is. So problem is, we want to search some specific element, that is 4, from this array we have. Okay, so to search this 4, normally if we see brute force, we will check every element one by one to check if this is our target element or not. We will check this one is target element or not. If not, then we will move towards next. If this is not, again we will move towards next. If this is not, again we will move towards next. If this is our required, we will return this element or index of its element. Okay, so what we are doing in brute force, we are traversing each and every element to search this this until we got our desired element. Okay, so this takes time complexity big of n. Okay, big of n. Why big of n? Because we don't know how many elements we need to traverse of an array. There are n elements we need to traverse. Like here we need to traverse 4 elements. That is an uh, if the element we want to search, that is 10, then we need to traverse 10 uh 10 we need to require 10 operations or 10 iterations to uh, to find our element, that is 10. Okay, so that is why we are placing big of n here, because we need to perform 10 operations, n operations, to search our desired element. So we can optimize this operation. We can optimize our algorithm, brute force algorithm, and we can optimize this complexity, time complexity, by using the binary search algorithm. Okay, so how we can optimize, let's see. First of all, we have target these 4. We need to search for spores. Okay, so let's understand before we discuss the uh, time complexity of this algorithm. Okay, uh, so first of all, we will set our pointers, that is start at left and right. So left pointer we will set at start of the array, and right pointer we will set at the end of the array. Okay, then we will loop through the array. We can use while loop. Okay, we will loop until left pointer crosses the right pointer. Okay, if left pointer is less than right pointer, we will loop our array until left pointer is less than right. If left is got greater than right, then our loop will not get executed. Okay, So in our loop, what we will perform, what statements we will write. In our loop, we will first of all calculate the mid using this formula. Okay. After calculating mid, we will perform two checks. Okay. We will first of all, we will check element at mid. Let's suppose. Okay. First of all, let's discuss this step. We will check element at mid is greater than at our target t, then we will execute this statement. If this is not true, then we will check if element at mid is lesser than target value, then we will execute this statement. If this both of these conditions are not true, then it means we will execute this statement. Okay, so I will let's understand these three or four steps by using above example. Okay, it will make you clear more. Okay, so first of all, initially we have left pointer here and right pointer here. So left pointer is pointing at starting index, that is 0. So we can consider index of this pointer as 0. We are just taking example. We are not here for size calculations. Okay. We can consider this index as 9. You can consider 10. So let's consider as 9 because we are starting from 0. So 0 plus 9 divided by 2, that is 4.5. So 4.5, because we are storing this value 4.5 value, that is float value, we are storing the return value or calculated value to into an integer variable, so that will be rounded up to 5. Okay, so sorry, 4.5. So 4 we have here the mid. So where is the 4 in fourth index? 0, 1, 2, 3, 4. Here is a fourth index. So here is our mid. Okay. So 5 is our mid. Sorry, fourth index is our mid. I can write here as 4. Okay, so that we can visualize easily. Okay, that's so yeah, this is index. Okay. Okay. Then what we will do, we will check, we will we have calculated our mid, that is at index 4, and element at index 4 is 5. Okay, we will check element index at index 4, that is 5, is greater than t. T is our 4. So 5 is greater than t. 5 is greater than 4. Yes, it is true. What we want to do, we want to do perform this operation, or we will execute this statement. What this statement means, we do not want to search from rest of our array, this right side. We will search only from this part of array. Why? Because we have checked our element at index mid is greater than the target. It means target is lesser than this element 5. It means our target that we need to find is will not be here anywhere, will be in this part of the array. Okay, so so what we will do, we will remove we will point this right pointer from ninth index to this here. This index will be basically mid minus 1. So mid index is this, minus 1 index would be this. Okay, so now I'm going to remove this 9, and we are here 0, 1, 2, 3, that is 3. Okay, now we do not need this mid, no, now because we have performed our operation, we will calculate our new mid. now this is our search space. In you have seen, you have noted, we have skipped our half of the array in first iteration. Like in first iteration we have whole array to search. Then after executing first iteration of the loop, we have only search space to restrict it to this. Okay, so uh we have performed this check first iteration. The condition, this condition is go true, and we have executed this statement. Then these condition will not be checked because the first check is got true. Okay, so now we will again we will again check whether we will again perform a check whether element at index mid, whether element at index mid is element, what is the element at index mid? Sorry, we have to calculate the mid first. So first of all, again this operation will get performed. Mid we will calculate, that is 3 plus 0, that would be 2.5. Our mid will be at 2, 0, 1, 2. Okay, mid is here. Okay, so element at mid is lesser than t. This condition will get executed. Then what we will do, element at index mid is 3 and target is 4. 3 is, this will not execute because mid, element at mid is not greater than t. This will be executed because element at mid is less than target. So our left will be get pointed to this mid plus 1. So mid is this, so mid plus 1 is this. So our again left will also point to uh, this 3 index. Okay, so now mid is no longer here, right is no longer, left is no longer here. Okay, so both of right and left pointers are pointing to same point position. So we need to, sorry, I forgot to place the condition. We need to loop until left is less than or equal to right. Okay, this condition basically will be based on our logic. So in specific logic we are discussing, the use case we are discussing, we need to require this condition equals as well, because some of the use problems we will see, we do not need to use this. So based on the problem nature, we will need to use equal sign, but overall the steps will be remain same. Okay, so now again this condition is true, left is equals to right, that is both are at index 3, left index is 3, right index is 3, both are equal. The condition mid again will get calculated, mid would be 3 plus 3 is 6. Mid will be also 3. Okay, mid will be also this. So element at mid is what? Element at mid is 4, 4 greater than 4? No. Mid, element at mid 4 is less than 4? No. Then this else statement we will get executed, we will return our mid, that is this index. Okay, so in this way this algorithm works. Okay, so I will give you a real life example as well, how it works binary search algorithm. Okay, so let's, before going towards the example, let's discuss its time complexity. Okay, so its time complexity of binary search algorithm is log of n. How it log of n? Because you have seen first iteration we have to search this whole space. Then after executing the first iteration, we are restricted to just this search space. We have only half of the search space, and after executing second time loop, then we have found the element. Okay, like we have found in third iteration we have found our element. Okay, so you have seen, if if for example, if I want we have to search using brute force, we have to loop first time, second time, third time, and fourth time. So we need to search, iterate 4 times to search. Then in this case we have searched our this element in just 3 iterations. Like if you have to search this 9, you do not need to search, you do not need to search it, iterate 9 times to search. No, you just need 2 or 3 iterations, or maximum 4 iterations, like that. Okay, so we do not need to search whole of array, complete array. So we are not going to traverse our array of n times. We are going to traverse array n times, but lesser, like half of the n. So we suppose we have a 16 our n. Suppose we are supposing just value here. We have 16 here. So 4 is power 2 is 16, and that is we are considering 16 as n. So if we take the logarithm of base 2 of 16, then we will got this 4 value. So it means we just need 4 iterations to uh, to search our element of uh, from the array of length 16. If we have array of length 16, we just need 4 iteration to search that element. Okay, so its time complexity is log of n. It's not big of n, it's big of log of n, because we are not searching complete, we are not traversing complete array, we are traversing just half of the array. Okay, every time we have a search space, like first time we have search space this complete array. So we are after it executing first iteration, we just restricted to this. Then we got our required element or desired element. Okay. Okay, so we are not going to search whole of our array. We are just searching half of our array. Okay, every time we have search space, we are searching half of the array, not complete. So that is why we have time complexity as big of log of n of this binary search algorithm. Okay, I hope you got the points clear. So let's take this real life example. First of all, for example, you have a book and you want to search some specific, or you want to open a specific page, like you can say 20 page you want to open, and you have randomly opened your book, and you have seen that you have opened 60 number page. That is not your desired page, and your desired page is 20 and you have opened 60 number page. So what you will do, you will skip the right part of your book to search 20 number page. You will search, or you will open, you will go towards left side of the book, left part of the book, to open the 20 number page, because you know the 60 number page is lesser than 20, and you know 20 will be always be right, always to be towards the right side of the book. So that is why you are going towards right, sorry, left side of the book. Similarly, if you have to search the element or the page that is greater than 60 number page. Let's suppose you want to search 80 number page or open 80 number page. You have to go. You will go towards the right part of the book to open the 80 number page, because you know 60 is lesser than 80 number page. So you will go towards the right part of the book, not towards the left part of the book. In this way, you can take the analogy of the book, or searching or opening page, your desired page. So the binary search algorithm works in the similar way. So I hope that's clear to you guys. So this is the algorithm. These basic some steps are these. We will use these basic steps. Maybe the conditions will change, maybe the logic, some logic will change, but the steps will remain same. Okay, so the time complexity is big of log of n. That's it. Okay, thank you so much.